Welcome back, everyone. So as we continue our conversation about gases, we are now going to move to talking about gaseous samples that are mixtures. So all of the examples that we have talked about so far and all of the problems that we've done so far, have all only been with one sample or a pure sample of one type of gas. But as you know, there are many samples of gases that are mixtures of compounds. Air is a prime example. Air is a mixture of not only oxygen, but nitrogen, a little bit of carbon dioxide. Gas cylinders that divers use, those are a mixture of helium and oxygen, different kinds of gases. Since gases can come in mixtures, we need to have some sort of explanation or some sort of mathematical expression to represent the pressures that each of those gas components exhibit in a mixture. That's where Dalton's law of partial pressures comes into play, which is fairly straightforward. It just says that if you have a mixture of gaseous molecules, the total pressure of that system, that is measured of that system, is equal to the sum of the individual pressures of each component in that mixture. Okay. So if I have three components, so for example, if I have something that has three components, oxygen, hydrogen, and nitrogen, the total pressure of that system would be due to the sum of the individual pressures of each of those molecules, the oxygen, the hydrogen, and the nitrogen. So that law of partial pressures is going to be useful to us as we continue to do some problems in this chapter, particularly when we do problems that involve collection of a gas over water. So if we get to do you're going to do an experiment, hopefully you'll get to do an experiment that's similar to what you see here in this picture. Although the gas that you are going to produce in this experiment is hydrogen gas, not oxygen gas. But there's a lab that is scheduled called the Aluminum Analysis Lab, and that lab involves reacting aluminum and generating hydrogen gas. And when you collect this hydrogen gas, you're going to collect it over water. So when it's in an apparatus similar to this. Why am I bringing this up now with regards to partial pressures? Well, when you collect that gas over water, be it hydrogen in that instance or oxygen in this instance, the pressure that is in the flask where you have collected that gas is equal to obviously the pressure due to that gas plus the vapor pressure of water that is being displaced in that upside down flask or upside down tube. So Dalton's law of partial pressures, the fact that the sum of the pressures is equal to the total pressure of the system, that is used in particular when collecting gases over water. Hopefully you guys will get to do this lab hands-on. If not, well, I'm sure we will find something virtual. But you will, at least in this chapter, be given data associated with a gas that is collected over water and have to do some calculations with it. And we will do a calculation similar to that in class and in one of the next videos.